Group 1's presentation of the OSI Model by Michael Robbins, Justin Ramsamy, Stephen Matuska, Anne-Marie Bright, and Crispin Morgan. The application layer, Layer 7, provides interfaces for applications to access services such as file sharing, message handling, and database access. It also handles error recovery for applications needed. The PDU at this layer is simply referred to as data. Common protocols found at the application layer include HTTP, FTP, TFTP, and SMTP. Computers with network OSs and some security devices operate at Layer 7 because work with these application layer protocols. Possible problems at this layer include missing or misconfigured client or server software, and incompatible or obsolete commands used to communicate between a client and server. The presentation layer, Layer 6, handles data formatting and translation for outgoing messages. It converts data into format specified by the application layer if necessary for incoming messages. It reverses the conversation if required by the receiving application. An example of functionality at this level is a web browser displaying graphic files embedded in a web page. A software component known as a redirector also operates at this layer. It intercepts requests for service from the computers, requests that can't be handled locally or redirected across the network to a network resource that can handle the request. Layer 5, the session layer, permits two computers to hold ongoing communications called session across a network. So applications on either end of the session can exchange data for as long as the session lasts. The session layer handles communication set up ahead of data transfers when necessary and session teardown when the session ends. Some common network functions this layer handles include name lookup and user login and log off. The session layer also manages the mechanics of ongoing conversations, such as identifying which side can transmit data, when, and for how long. In addition, a process called checkpointing is performed at this layer. The transport layer, Layer 4, manages data from one application to another across a network. It breaks long data streams into smaller chunks called segments. Segmenting the data is important because every network technology has a maximum frame size called the maximum transmission unit, or MTU. To ensure reliable delivery, the transport layer also includes flow control and acknowledgements and handles resequencing segments into the original data on receipt. Layer 3, the network layer, handles logical addressing, translates logical network addresses or IP addresses into physical addresses, MAC addresses, and performs best path selection and routing in an internetwork. As you can see, this layer performs the same task as TCP/IP's internetwork layer. It's also the traffic hop for network activity because it provides access control. The PDU at this network layer is a packet. Software components working at this layer include IP, ARP, and IMCP from the TCP/IP protocol suite. Layer 2, the data link layer, works with frames and is the intermediary between the network layer and the physical layer. It defines how many computers access the network medium, also called media access control, which is why the MAC address is defined at this layer. The PDU for this layer is called a frame. The data link header contains fields for source and destination addresses. The destination address is a hardware MAC address of the computer to which the frame should be delivered, or of an intermediate device, such as a router. After receiving a frame from the physical layer and verifying the destination MAC address and the CRC, the data link layer strips its header and trailer information from the frame and sends the resulting packet up to the network layer for further processing. The software component operating at this layer is the NIC driver, and the hardware components include NICs and switches. Last but not least, the job of the physical layer is to convert bit signals for outgoing messages and signals into bits for incoming messages. The type of signals generated depends on the network medium. And the physical layer also specifies how to encode ones and zeros. Encoding is representing zeros and ones by a physical signal, such as electrical voltage or light impulse. The network components working at the physical layer include all the cables and connectors used on the medium, plus repeaters and hubs. Problems occurring here are often related to incorrect media termination, EMI or noise that scrambles the signals, and NICs and hubs that are misconfigured or do not work properly. I'd like to especially thank YouTube user Free Dub and Bass for the song provided, me for bringing cheese nips and not sharing, Mike Robbins for not coughing during all of our recordings, and lastly Justin for being brown and bringing ethnic diversity into our group.